Good morning. I'm Daniel Ranque and a member of Group 4, reporting on the topic of laser on light and electromagnetic. First, I'd like to define the word laser. Laser is an acronym for light amplification by stimulated emission of radiation. Next, what are the properties of a laser? First off, the first property of a laser is monochromatic. Below we can see two pictures of light. On the left is a basic laser light. On the right is a normal light passing through a prism. Monochromatic means from the two root words, mono means single or one, while chroma means color in Greek means one color. A laser light only emits one color. In the example on your left is a red laser light, while on the right, a normal light is comprised of more than uh, is comprised of a wide range of colors when refracted through a prism. Next property of a laser is that it's directional. Shown below are two pictures. On the left is a basic laser light again. As you can observe from the picture, it has a narrow beam that is highly directed, which means it only goes through to one direction, but can also be refracted through the use of different angled mirrors. On your right is a light bulb. Compared to a normal light, uh, light uh, a normal light goes in a wide range of directions depending on its source and its casing or surrounding area. Next property of a laser light is coherence. A laser light is considered a coherent light because a laser can emit a light that has the same frequency and same phase differences, while an example of an incoherent light is an incandescent light bulb generates or emits a light of unequal frequency and varying phase differences. These three properties of a laser significantly increase the danger in handling these types of devices because the amount of energy it can deposit in a small surface area is increased dramatically as to compared to normal light. Next, we'll talk about a laser device component, which is common among most lasers. First is the lacing medium. The lacing medium can be a gas, solid, or a liquid, which is then excited by to emit light or and generate photons. Below is a picture of a basic common laser component setup. Next on that is the energy pump or excitation mechanism. This component allows or enables the energy from an energy source to be pumped into the material to cause the lacing material to emit light and generate photons. The next component is the optical cavity. The optical cavity usually comprises of two reflective surfaces. One a completely reflective surface, another is a partially reflective surface, also known as oscillator. Inside this optical cavity, we place the lacing material and connect it to the excitation mechanism. Next, I would like to know, I would like to answer the question, how does it work? First, the energy from the energy source is fed into the medium using the excitation mechanism or energy pump, which allows the lacing medium to emit light and generate photons. These photons decay over time, but these photons are of equal wavelength and phase and direction. Next, these photons are inside the optical cavity are reflected back to the material through the use the of the reflective material inside the optical cavity. This occurrence increases the number of photons inside the optical cavity, while a portion of the photons generated are reflected back in the optical cavity. The rest emerge as stream of a concentrated laser beam. Next, we can classify the types of lasers through the type of medium it is used inside the laser. The first of the type of laser I'd like to discuss is a solid state laser. This kind of lasers make use of a lasing material distributed in a solid matrix. An example of which is the yttrium aluminum garnet, also known as YAG. This YAG is used in a YAG laser, which is used in construction or industrial uses. The next type of laser is the gas lasers. This gas laser has an output of a visible red light and can cut hard materials. They make use of an example of which is the Umicore CO2 laser, which makes use of CO2 as a lasing material. The next type of laser I would like to discuss is the excimer. The excimer is derived from two words, excited and dimmers. The excimer excites a mix of gases and inert gases to produce a dimmer, which generates photons and emits light at an ultraviolet range. This type of laser is commonly used uh, medical in the medical field as a refractive surgery medium or a treatment for skin disease. The next type of laser is the dye laser. The dye laser makes use of a complex organic dye which can be tuned to alter its wavelengths. An example of which is the rhodamine 6G setup below in the Institute of Massachusetts. The next type of laser is the semiconductor laser, or also known as diode lasers. This type of laser is a non-solid state laser and consumes low power. An example of which below is a semiconductor laser. Thank you and goodbye.